Good evening, friends. Okay, so let us solve one more problem on springs. When I started looking at the concepts in springs, every concept is really something like you need to work a lot on springs so that all the concepts can be covered. So there are several problems like this. Okay, most of them have been taken from H.C. Verma, but it is fruitful, I feel. Okay, so to work on each problem. It could be applied for any grade, any competitive exams, whatever it is, but still, I feel these problems are really worth enough. Okay, let us start working on this. A block of mass 2 kg. There's a block of mass 2 kg here, another block of mass 2 kg here. You kept a spring here, and it's on a frictionless horizontal surface. The surface is a frictionless horizontal surface, and it is moving with a velocity of 1 meter per second. See, when I say it's 1 meter per second, the moment it strikes it also, okay, it touches the spring, it's also 1 meter per second. And this mass is at rest. The spring constant of the spring fixed at one end is 100 Newton per meter. So the value of K is already given to you. The value of K is given to you. Okay. And find the maximum compression of the spring. The moment it hits it, what is the maximum compression? So the solution given by the student is like this. Kinetic energy of the 2 kg mass. See, why should the spring compress? Because you are giving some energy, and as a result of it, spring gets compressed. Kinetic energy of the mass is nothing but half mv square. So m is 2 kg, v is 1 meter per second, and divided by 2, mv square by 2. So which comes out to be 1 joule. And this should be equal to half kx square. I have written this 0.5 kx square. Okay, so we can equate these two. So what do? I equate this 0.5 kx square, which is nothing but 0.5 into k. I have substituted k is equal to 100. So thus it is 50 x square over here. Now equating, we get 1 joule should be equal to 50 x square, or x is equal to root of 1 by 50. Okay. And when I do this, I get the answer as 0.141 meter, or this is equal to 14.1 centimeter. The spring should get compressed by 14.1 centimeter. Spring constant is given, find the maximum compression. Maximum compression is 14.1 centimeter. This is the answer that has been given to us. Now, this is a misconception. Okay. This method is incorrect. Why this is incorrect? Now, while doing this, we have assumed that whatever energy I gave here, the entire energy has got transferred to the spring, and spring has got compressed. But unfortunately, you should realize that the entire system is now in a frictionless system, or maybe even if it is friction, until and unless, okay, it is not fixed, this object is not fixed. When you give some energy, this energy partly goes in compressing the spring, and then it also goes in moving this object. Okay, now you can ask me, if that is the case, is it like an elastic collision wherein you give a force over here, okay, you give a velocity over here, and this velocity is entirely taken over here? No. Okay. So therefore, now let us see what exactly happens here. Let us understand the scenario before we start solving the problem. Now, when the object goes and hits the spring, now what will happen? The spring will get compressed. Okay, let me write down the stages. Yeah, this pen is not writing. Just a moment. Just a moment. Let me take up a new pen to continue. Just a moment. Okay. Now I've changed it. I think it works well. So what we have assumed is, okay. Let me. I told you regarding what exactly happens over here. When the 2 kg mass just hits this one, now what can happen? Initially, the block and the spring is like this. It's like this initially. This is the way how it looks like initially when it is just striken this one here. Then after, let us say, 1 millisecond, now what can happen? This object would have been like this, and this spring would have got compressed like this. Okay, and the object would have also moved a little bit. Okay, and then after some more time, what could have happened? This object would have compressed it a little bit more, and then this could have been the object, right? Now what's happening is this is moving further. Okay, this is also moving. That means part of the energy is given to the spring, part of it is given to it, of course. But this continues as long as after some time you observe the distance between the objects will remain a constant, which means Whatever speed this is moving, the same speed this object will also be moving. Initially, what was it? Initially, this object was at rest. This object was moving. Now, when it compresses the spring, the speed of this object reduces. Okay, and this object gains its speed. Now, as time proceeds, okay, let us say what was the initial speed here? I said 1 meter per second. Okay, this is 1 meter per second initially. Might be this becomes 0.8, this might become 0.1. Then maybe this becomes 0.6, and this can become something like 0.4. And sometime here you observe this will become 0.5. This will also become 0.5. Now, when both of them become 0.5, then that is the maximum compression of the spring. Okay, which means that the relative velocity between the two objects will be equal to 0. Which means what? See, let us find the relative velocity here. Let us say the velocity here is v1. This velocity is v2. Now, what is the relative velocity here? v1 difference v2, which is not equal to 0 here. Here, again not equal to 0. Here, not equal to 0. But only here, if you see 0.5 minus 0.5 is equal to 0. Remember, this is a condition that we require if we have a spring connected between two objects and I have given a velocity r. If this is a velocity given to this object or the object is moving with the velocity, then the spring will contract or expand or anything can happen to the spring as long as the relative velocity is not 0. But the moment relative velocity becomes 0, then that is the maximum compression being observed. Okay, this is the point where you observe the maximum compression. Okay, this has not been put in the books. Okay, but you should know about this one. Now towards it. Now how do we solve it? Now the problem truncates to something like this. Now you know this is an elastic collision. Okay, and now we will apply the conservation of momentum. Now what does the conservation of momentum say? What is the initial momentum of the block? Initial momentum of the block is 1 multiplied by, what is the, sorry, 2 kg. So 2 kg multiplied by 1 meter per second plus, this was at rest, 2 kg multiplied by 0 should now be equal to, now when both of them are moving at the same velocity, it is equal to saying that both of them are sticking together and moving together. Do you agree? Okay. So therefore, now both of them are moving at the same velocity. That means the total mass, or if you want, you can say 2 into v plus 2 into v, because both of them are moving at the same velocity. You can write like this also. Okay. So therefore, this should be equal to 4v, and this should be 2 into 1 is 2, plus 2 into 0 is 2. So 0 plus 2 equal to 4v, or v should be equal to 2 by 4, which should be equal to half unit meter per second. Okay. So that means this, when this condition is achieved, then definitely the particle, the spring has been heavily compressed. This is what we come to know. Okay. So now the next is, now what we need to do? Apply the conservation of energy. What does the conservation of energy tell you? Just a moment. Pen is not writing correctly. Just change my tablet once again. Just try doing it, but unfortunately nothing is working. Now let us try. Now, so here what did we apply? We applied our conservation of momentum. Now let us apply conservation of energy. Conservation of energy. So when you have conservation of energy, what does it tell you? Initial kinetic energy. Okay, initial kinetic energy of the object will be equal to, what is the initial energy? Which should be half mv square. Which should be half m2 into v square into 1 square into 1 square is equal to, this is 1, not 11. Okay, bada 1 hai. Okay, 1 square should now be equal to, now what happens? Now this energy that you gave has compressed the spring and is also making the objects to move with a uniform velocity, right? So therefore, this should be half into, now both the objects are moving with the same velocity, so which means half into 2 into 2 kgs, 2 kgs into v square. What is v square? 1 by 4, 1 by 4. This velocity, right? Plus half into k into x square. What is k? Okay, k is already given to you. What's the value of k? K is 100. Okay, k is 100 into x square into x square. So what will now happen? This 2, this 4 goes away. And now you have half here, you have half here, you have half here. It goes away. So you have only 2 here. So 2 should now be equal to, and here there's nothing remaining. So you have 1 here plus 100 into x square. 100 into x square. Okay. It's multiplied here. Remember this. Okay. So therefore 1 should be equal to, this implies 1 should be equal to 100 x square, or x should be equal to 1 by 10. Because 1 by 100 becomes x square equal to 1 by 100. And this x equal to, taking the square root, you get 1 by 10. What is this now? This is 0.1 meter. This should be equal to 10 centimeter. This is clear. So the answer should have been 10 centimeter and not 14.1 centimeter. Okay. So this is how you need to solve this problem. I hope you have understood the concept behind it. The major concept here is the relative velocity of blocks connected by a spring will be equal to 0 once a collision happens. Okay. This is a major concept. Remember this concept. This would be very, very useful. Right. Okay. So if you like this video, do share and subscribe to my channel for further updates. Thank you, friends, for watching this complete.